Okay, so my name is Sachin Deshpande, and this is focused on the work done in the JVET group related to the neural network post filters, and that's why the title is standards based, and in particular focusing on the generative AI work. So, in terms of introduction, I will describe what is called VSCI version 3, that is the versatile supplemental enhancement information messages, which includes the original neural network post filter design. And then in the newer version of that, called version 4, is where the generative AI functionality was added. So I will focus on that, show some examples, implementations. What is coming additionally in terms of technologies that are under consideration for further extensions and some conclusions. So JVET has been working on mainly two things that are related to neural networks, and one is called neural network video coding, which is focused on the compression efficiency, sort of similar to some of the previous talks we looked at. And then this neural network post filter, which is a work that is part of the versatile supplemental enhancement information messages, and that basically applies to post filtering. So you have a video, you want to improve its quality after it's decoded. So version 3 already includes the NNPF and defines several what are called as purposes, as in what is the goal of your particular post filter. And then version 4 adds the generative AI capabilities. So because we have short time, I will not talk about every bullet point on every slide. First, a very quick introduction to the version 3 NNPF core design. So there are two main messages defined in SCI, VSCI, called NNPFC, which is Neural Network Post Filter Characteristics SCI message, and then another one which is called NNPFA, which is the activation message. And then additionally, you can signal in band some neural network data using this ISO IC 15938-17 neural network format. So in the talking about the NNPFC SCI message, it has several different syntax elements, and that is the one which defines the actual neural network that is used as the post filter. And some of the important ones are NNPFC purpose, which indicates what is the purpose of this filter, and I have a next slide on that. NNPFC ID, which assigns an ID to a filter, allows multiple filters to be managed and used. A mode IDC, which currently defines two different modes. One is for in-band signaling of the neural network post-filter data using that ISO IC standard, or a mode 1, which allows you to just signal a URI and then have the data be pulled externally. And then a property present flag, which can provide a lot of properties of that neural network post filter. So here are the predefined post filter purposes in the version 3. So there is a general quality improvement. Then there is a chroma upsampling, resolution resampling, so upsampling or downsampling of resolution, including super resolution, for example. Picture rate upsampling going from 60 hertz to 120 hertz, or any kind of picture rate upsampling. Bit depth upsampling going from 8 bit to 10 bits. Colorization going from black and white videos to color videos, and an application defined purpose where you have your own NNPF, which turns every picture into a cartoon. Well, use an application-defined purpose for that. The NNPFA activation SCI message works together with this NNPFC, so you can signal a first NNPFC for visual quality improvement, a second one for picture rate upsampling, and then you have an activation message which can say, okay, for such and such pictures, activate this particular NNPFC, which was signaled to have an ID, and you indicate its ID in the activation filter. And then we also have this concept in VSCI of cancel and persistence, where you don't need to keep on signaling a filter message every picture. You can just say, okay, from now on, apply this message neural network filter until I tell you to cancel it. So then one more information about this neural network format, which is defined in MPEG, and it is very efficient. So it can support compression to less than 5% of original size. It has several tools such as quantization, deep KBAC, which is arithmetic coding, and then various pre-processing methods used in neural networks typically. So what did the version 4 add? So the basic version 3 model and the framework of NNPF is extensible and versatile. So in version 4, some of the new purposes were added. We'll look at that. Text prompt signaling architecture is supported, and that is also able to be updated dynamically. So these are the two new purposes on top of the ones that we saw in version 3. So temporal extrapolation, which relates to I have this video and I want you to extrapolate how it will look like for future frames. And that may seem little strange, but for example, for cloud gaming or some other applications, that may be something that you want to use where you predict the future pictures. Spatial extrapolation, where you have a particular dimension of the picture and you want to fill it out, or even selectively reduce its, so remove some of the content intelligently. So here is where for in version 4 for spatial extrapolation you can actually signal a text prompt. So you can say, okay, fill this frame where the area that is filled should look like grass or something like that. And I'll talk more about that. So it allows the generative AI to be used for spatial extrapolation. And in particular, this text prompt that is signaled in the message is passed as a auxiliary information to your post filter, because post filter needs to use it. And that framework we have, it passes the images, but it also can pass some auxiliary input. And this is one of the new auxiliary inputs. So again, it can the text prompt actually can be signaled in band in an NPFC message, or it can be updated in NNPFA message, or it can also be externally signaled. And as I mentioned, there is a particular auxiliary input bit that you can set, and then it will basically say, oh, I do have this text prompt signaling, and pass it to my neural network post filter. Some exact way in which you select an NPFC or an NPFA or external is shown on the right side, which I'll skip right now. Then the dynamic text prompt updates, what it actually then supports is you can start with a particular prompt, and then as your video progresses, you can update it by using the same NNPFC message, but just change the prompt via NNPFA. And that provides the flexibility of reacting to a scene change, or if you want to change something as the time progresses. So some more technical details about what is in version 4. So in particular, the input tensor structure is defined such that this auxiliary information is passed along with the image data. And so in particular, we can pass the original image data, which are the decoded images, the prompt information, and then we can also additionally pass a seed value, so that if you know that, for example, you want to have somewhat of a reproducible generation of what it generated in the generative AI, then if you pass it the seed value, most of the times it generates very consistent results. Additionally, obviously, if you also signal the spatial offset parameters. So if you have your original picture of certain width and height, you can specify whether you want to extend your area to the left, right, top, bottom, and that's signaled via these 4 syntax elements. And those are exponential golem coded, which is SEV assigned value, because you can also ask it to remove some content. So if you signal negative values, you are talking about partial content removal. And then NNPF already via version 3 supports this patch-based processing, because as we know, the computational requirements are high, and so you want to operate in patches. So there is the signaling of patch width, patch height, and overlap for seamless blending of the patches. Then the version 4 additionally has 2 other things which I want to quickly mention. One is you can, instead of using the same NNPFC message, you can use the same NNPFA message, but you can pass the original image data, which are the decoded images, the prompt information, and then the auxiliary input bit. So in particular, we can pass the original image data, which are the decoded images, the prompt information, and then we can also additionally pass a seed value, so that if you know that, for example, you want to have somewhat of a reproducible generation of what it generated in the generative AI, then if you pass it the seed value, most of the times it generates very consistent results. have these optimizations be mainly for human viewing or for machine viewing. So earlier we had this paper giving an introduction to the machine video coding work going on in MPEG related to VCM and FCM. So for example, if your neural network was just signaling data which is geared towards machine analysis, then you can indicate that in your NNPFC. And each of those viewing indicators have four possible values indicating whether this is optimized for human viewing or machine viewing. And then the seed parameter, as I said, allows more reproducible generation. So I'll show some practical examples. So this is an original input image that would come out of a decoder. It was a image I took, video I took in Valley of Fire State Park. And if you don't give a text prompt, so it's also supported that you can just do the generative AI without a text prompt, like a blank text prompt. Then in this example, I was signaling the parameters such that we want to extend by doing generative AI on the right side of the image. And so it basically adds some pixels there in a consistent manner to the original image. Now, instead, I can pass a text prompt of, say, cactus tree here. And so now what gets added on the right side is some consistent landscape plus some cactus tree got added. Instead, I could give a text prompt of road, and this is the result of that. Um, one of the issues is how much is the computational requirements of this. And in the standardization world, you're not directly working on a product, so people have their own implementation. I just want to give a general set of aspects that people usually consider. So obviously, we know you probably need a GPU to do that. There is some latency involved, so you might do some progressive generation of images or pipelining. We have our own internal implementation, which uses stable diffusion, Excel inpainting. We tried it on an NVIDIA GPU with this PyTorch diffusers and Python version, and it's doing pretty well, but it's still quite complex in terms of the computation requirements. So the bitstream overhead of text prompt obviously is very negligible, but additionally you typically can compress this. One of the issues is, so remember when you signal this message, and for example, if you are signaling a neural network along with it, that's quite a bit of data. But typically, you would have one neural network signal for your entire video. And one example I want to give you is, so for example, the original neural network was, say, 550 megabytes, and through this ISO IEC 15938-17, it got compressed down to 9 megabytes. That's one sort of very high capacity neural network. In other practical cases, you may have a neural network which is like, let's say, with only 2 million parameters, maybe let's say 2 megabytes, and it gets compressed down to 0.2 or 0.4 megabytes. So it's doable. One last thing I want to describe is the work continues in the VSCI for adding additional functionalities to this neural network post filter. And there are two main things that are currently accepted in technologies under consideration, which presumably at some point would end up in a version 5 of the VSCI. And one is temporal extrapolation with generative AI. So the one I showed so far, which is standardized in version 4, is only for spatial extrapolation. And now we are adding support in this technologies under consideration called in JWET and MPEG-S TUC for the temporal extrapolation, again with the text prompt signaling. And additionally, there is support for multiple extrapolation. So instead of generating just one possible extrapolated image, you want to generate multiple of those. And there are currently two ways supported to do that. One is either you can invoke your neural network post filter once, and it produces more than one possible outputs, or you can just invoke it multiple times, and there is some signaling for that. So I talked a bit about deployment considerations, so I'll just skip in the interest of time. As a conclusion, the VSCI version 4 seamlessly provides these generative AI capabilities on top of version 3 NNPF framework. The key aspect of that is the text prompt signaling, which can be static or dynamic, and the NNPF architecture's flexibility ensures some broad applications that could be potentially enabled through this. And having this in a standardized manner is very important, because now and that standards framework is versatile and flexible enough that you can use your own format, you can update it or not, you can signal it in band or out of band, and so forth. And as we saw, this version 4 started generative AI, and we expect some more additions in future, and all of them are backward compatible. So that's all today. Thank you.